Hello, and welcome to the latest episode of the Isaac Newton Institute podcast. My name is Dan Aspel, I'm the Communications Manager here at the Institute, and today I'm joined by Professor Chris Budd.
Hello there.
So Professor Budd is attending a current programme at the Institute. He's a programme participant in the Geometry, Compatibility and Structure Preservation in Computational Differential Equations programme. Not only that, but some subjects we're going to be touching on are that you have a real passion for maths communication, and that a lot of your current work relates very strongly to meteorology. But as I said, you're a programme participant here at the moment. However, I've got a sheet of paper in front of me here, which has your record of all of your attendances at the Institute. And you began with the inception of the Institute back in 1992. And since then, you've been really quite a regular visitor. There are a great number of programmes here. So I can hand you this list and we can talk through it. So to begin with, should we talk a little bit about your association with the Institute and how it's been to know it over the years?
Indeed. Well, my association with Cambridge goes right back to 1979, when I came up as an undergraduate. So I studied maths. I was at St John's College, and I did 3 years as an undergraduate and then did the fourth year, which is part 3. So I got to know Cambridge very well in that time. And there's one particular person that I worked with a great deal in part 3, was a guy called Ari Isserlis. And I'm still working with him. He's at this programme right now. This is 40 years on from when I came up. And that's been a kind of constant point of collaboration with Cambridge. So I've been visiting him and his group ever since. And so it was very natural just to fall into the Isaac Newton Institute when it got started.
Yeah. And was your ongoing relationship, was it just professional, or were you friends as undergraduates?
So Ara was the supervisor for my Part 3 project.
Okay.
And he did offer me the opportunity to do a PhD with him, but I'd felt that 4 years at Cambridge, even though Cambridge is wonderful, was enough. And I moved to Oxford, but continued a professional collaboration with him, and I've written many papers with him since.
Yeah, what a fruitful 40 years this must have been so far. And obviously you're working together now. Does this feel like the culmination of 40 years, or is it just another chapter in this long work?
It's a long programme of work. So the area we're working in, which is what's called geometric integration, which is developing numerical methods which preserve these qualitative features of the problems you're trying to solve, is just a huge thing. And it started in kind of small beginnings in the 1980s, and has just grown and grown and grown. And we are just continuing to work on hard problems in the area, really.
And there aren't, and please correct me if I'm wrong, because you have a distinguished career in mathematics behind you, there aren't other places in the UK that can operate in quite the same way, perhaps, as what you might achieve here.
Well, the Isaac Newton Institute is the only place in the UK which gives you the opportunity to work over a sustained period of time. So this is a 6-month programme, and I'm not here every day. Bath is close enough that I can kind of come and go and take part in the programme on and off. There are other places, for example the ICMS in Edinburgh, which have concentrated programmes of work which last a week, and that's nice as well. It's a different way of working.
Absolutely. And as I mentioned earlier, I've got a sheet of paper here printed off from our database. If I can hand that to you.
Right.
You'll find your personal details, which you shouldn't read out.
Absolutely.
At the front.
Especially my age.
But a little further on, there's a little record of the programmes that you've attended.
Yes.
Are there any memories which these bring up, or do they in any way relate to what you're doing now? I've put you on the spot, but I think it'd be quite interesting to have a look through them.
Well,
you'll see the little codes here, which
yes.
are our own reference, and the names of the programmes on the left.
Yes. So I think one of the programmes which, for my mind, was a really important one was the multi-scale numerics for the atmosphere and ocean. That was about 7 years ago. And that programme started, for me, off in a particular research area, which proved to be very fruitful. And one of the most fruitful things about it was, at that programme I met a chap that had just done part 3 and was just coming along to the programme because he was in Cambridge and wanted to look at it. And I was very impressed with this guy. He went off to do a PhD at Imperial College, but I kept in touch, and I got a big grant to work in this area. And then he became my postdoc, and he did incredibly well. He was a fantastic postdoc. And it was the grant and that work and the postdoc and the collaborators all started in that programme.
Yeah.
So for me, that was a really important programme.
Yeah, and to us as well. I mean, all of the conversations which occur between the director, the deputy director, the administrator, all the senior team here, the word which always comes up is collaboration. And in many ways, that's the purpose of the Institute. If we hear stories like that, then that means that the Institute has worked.
Very much so. So, I mean, I started this joint collaboration between Imperial College, Reading, and the Met Office, and the collaborators and the person all started at that programme. So it was an absolutely fantastic programme.
Yeah.
It had a very other nice personal thing that my family visited me whilst I was here, and my son wandered around Cambridge and said, I'd like to go to Cambridge. And the next year he went to Cambridge.
Oh, wow, how exciting.
Yeah.
Which college did he go to?
He went to Trinity.
Oh, right, okay. In mathematics?
He did mathematics, yes.
Yeah, wow, okay. So how do you feel about that, being a St John's
well,
fellow associate?
I'm very happy. He went round Cambridge. I said to him, I'm here at the programme. My wife and he just wandered around Cambridge and went round all the colleges. And he said, I want to go to Trinity. And I said, why do you want to go to Trinity? He said, well, there's lots of mathematicians there, so I'll be able to make lots of friends.
Oh, very good. Well, I hope it worked out.
And that worked out very well. He went on to do part 3, and now he's doing a PhD in maths, and decided to move away from Cambridge, and he's at the University of Delft in Holland.
Wow, okay. Oh, how exciting. Yeah, well, I wish him all the best, obviously.
Yeah.
I think another interesting thing to move on to is you mentioned the Met Office there.
Yes.
Obviously, I said at the beginning that quite a lot of your work relates to meteorology. And in fact, I believe you were a workshop participant in a programme which finished last month, which was relating to landscape decision making.
That's correct,
which
yes.
in a way must tie into that, I presume.
Very much so.
Yeah.
So why have I been involved with 2 programmes? So I'm very, very interested in computational mathematics, which is why I'm here. I'm also very interested in environmental science. And the only good way, I think, to make kind of careful predictions of what's happening in the environment is to do careful computations. And to do that, you need to use really careful numerical methods. So the numerical methods that we're developing in the program I'm in at the moment can then be used to look at the environmental problems that came up in the program that I participated in most recently.
Wonderful.
And there's the link.
Yeah.
And so when you hear about things like the IPCC doing climate modelling and looking into the future, I hope that they're using reliable numerical methods, and it's the purpose of the current programme that we're in to develop exactly those sort of methods.
Yeah, and do you tend to see similar figures? I know you mentioned earlier about a long-term collaborator, but across those programmes, are there other people with your dual interests?
So, interestingly enough, the people that I was mostly working with in the previous programme were statisticians at the University of Exeter, who I do collaborate very strongly with, and meteorology is a combination of mathematical modelling, of computation, but also careful data analysis and statistics. And it's the 3 bits which make it accurate. And so my collaborators in the previous programme, what I call the 3 Peters, the 3 mathematicians from Exeter all called Peter.
So I know 2 of them. It's Peter Challoner and Peter Cox.
Yes, and there's also Peter Ashwin that turned up later in the programme.
Okay, right.
And fantastic mathematicians, all of them, great friends, and I've been collaborating with them for years.
Yeah, how exciting. And tell me about your work within that field. What motivates you within it? I mean, it obviously has more obvious public impacts, I think, than perhaps some mathematics does.
So, well, meteorology is a really nice area to work in for 2 reasons. As you say, has an enormous public impact. So if people say, what are you doing? And I say, I forecast the weather, that's kind of honest. People understand. If they say, what are you doing? And I say, I solve partial differential equations, which is exactly the same thing.
Yeah.
Less so. So that's one reason. The other reason is that the mathematical challenges are enormous in meteorology, and so it absolutely stretches you, and pretty well every bit of maths that's ever been invented somehow seems to be involved in meteorology somehow. And I find that's great. And another really nice reason is that I collaborate a lot with the Met Office, and the people in the Met Office are very good scientists, and it's a real joy to work with them.
Yeah, it's really fascinating you say that about how all branches of mathematics are involved in weather prediction, because from a layperson's point of view, you look at global weather systems, and it seems like there must be too much data to handle it all. There are so many factors. And
there's a lot of factors. We estimate that to make a weather forecast, it takes about 1 billion amounts of information. There's 1 billion unknowns in a weather forecast that you need to work with. So there's an awful lot of unknowns. And actually there isn't really enough data. A typical weather forecast uses about 1 million pieces of data.
Wow, okay. So
to inform those 1 billion unknowns.
Okay, and those I mean, that's obviously a factor. It's, you're using one set to predict 1,000 times as much information. So is that the root of any of the unpredictability?
Well, there's all sorts of reasons weather's difficult to predict. One is that it's actually quite hard to know what the weather is doing. So you might say, well, it's obvious. I look out the weather window and it's kind of drizzly, which is kind of what it is at the moment. But that's only what's happening out the window. What's happening a mile away, I don't know. So knowing the current state of the weather is actually quite hard to get accurately. So that's one reason. Another reason is the sheer complexity of the system, which you mentioned. There's lots going on. And a third reason is that even with a perfect system, even if you knew it really well, after about 10 days, the effects of chaotic behaviour, the sort of evolution of errors as you go down, they just get bigger and bigger and bigger. So after about 10 days, a weather forecast ceases to be useful as an accurate prediction.
And this actually leads us on, I think, to the other point I mentioned for discussion, which is about communicating maths to the general public. And there probably isn't a situation where it's more apparent than that, is there, than with weather forecasting, because every member of the public to some degree wants to hear about what the weather's going to do.
Well, I like to say that with weather forecasting you have to be honest every day, because if you get it wrong, people know. And that's a little bit of a difference between that and the closely related field of climate forecasting, where you're trying to make forecasts 10, 100 years into the future, and it's much harder to test whether those are right or not.
Okay, yeah. And that's how do you feel then generally about mathematics ability, or the ability of those within mathematics to communicate with the rest of the world?
Well, I believe I'm seeing a golden age of maths communication. So about 30, 40 years ago when I was an undergraduate, there wasn't very much. There were a few very notable individuals, Ian Stewart, Christopher Zeeman, fantastic people, but they were in the minority. What we're seeing now is a much greater community of maths communicators. So maths is more present on TV, it's more present in the media, which is great. There's still a lot more that we need to do to get it to the same level as other areas. I mean, like cooking, for example, but I think we're seeing a huge growth from what it was a few years ago, and I'm very encouraged by that.
Yeah, and what do you think it can offer the world? How can it change things for the better?
Well, mathematics is increasingly important in the modern world. Everyone talks about big data and algorithms and the effect these have on our lives. These are all mathematical things. So if you go shopping and you buy things, people record what you buy, that's giving data on you, and that is processed using algorithms to, for example, give you ideas of what you might want to buy later on. Most people rely completely on the internet, which is all heavily reliant on maths. Google is a mathematical algorithm which was invented by two mathematicians from Stanford. So a lot of the technology that we are currently involved with is mathematical, and it's going to get more and more so. And so understanding the role maths is playing, and will play even more in the future, is I think an enabling technology. It's a way of people being able to understand more about the way things are going.
That's a really inspiring way of putting it. Thank you very much. So as I mentioned earlier, you're here currently as part of a programme. I believe that today, you're just here for the day, aren't you? But
only today.
But you will be back. And
I will be back, yes. I'm only here for today because I'm off to Canada on Thursday. There is a rival institute in Canada called the Fields Institute, and I'm going to take part in a programme on industrial maths there next week. And that'll be great fun, taking some of my students. But I will be back. I'll be back on and off quite a lot between now and December.
Oh, well, I wish you very safe travels. I'm always very envious when I speak to academics because the amount of travel involved does seem quite appealing. And I know that you will enjoy yourselves very much when you're attending these.
Well, if I could say, it feels like coming home to come to the Isaac Newton Institute. And it's just so nice to be here. And just to be, I'm only here for a day. Well, not quite. I was here for supper yesterday, so I had supper with loads of mathematicians. I've had intensive conversations already this morning, and have more intensive conversations this afternoon. And that will set me up to think about lots of things. And so when I come back next time, which will be for a longer time, we can really get down and do some mathematics, and I'm really looking forward to that.
Oh, fantastic. Well, I wish you all the best. And Professor Chris Budd, thank you very much again for joining me. And I look forward to catching up with you as the programme progresses.
I look forward to it too.
Thanks so much.